Hello, in the virtual world. This is Tom and Tom from MIT Lincoln Laboratory. I want to start off by saying thank you to the aerospace team for inviting me to speak at the Optical Communications Workshop. Second, I want to hope everyone's doing well, probably at home, much like I am now. And so it's a little bit different format for a conference talk, but today I wanted to talk about a few things related to LaserCom. It's going to be a little bit different than in the past. So my colleagues at the laboratory have worked on LaserCom for decades at this point. And when I was thinking about types of conference talks we often give, there's at least a couple. There's one, system application talks. If LaserCom works and we do it this way, it can really do a job that's not able to be done now. It's just awesome. It's done differently. Second one, kind of bit of talk we've given in the past is more technology. Technology is ready. We've tested it. Here's how we glue it together. And I can go do that system application we just talked about. The third kind of conference talk is usually the success. Hey, we went and ran the demo, it worked, everything was awesome. And so we have certainly some of those talks we could give, and I'm hoping actually the other members of the conference share some of them. I'm excited to hear about that. But I decided to go kind of down the fourth track and say, I'm going to assume LaserCom works. And so let's do some time travel. So we're now 10 to 15 years in the future. There's 10 or 12 different LaserCom systems, all working, all doing different jobs, all doing phenomenally well, all done by different people. In that world, what are potential regrets? And if we think about those regrets now, what can we do to avoid them? And so there's probably a couple of different ways to get there. Predictions are hard, particularly about the future. I think that's a Yogi Berra quote. But we can use other communication systems as examples. And so I was trying to think through old cell phone technology. When I first got a cell phone, roaming charges didn't always work when I drove across town lines, and then certainly didn't work when I went to Europe, and there was all these restrictions. It was big, it didn't have a lot of functionality, and so there is clearly, if we look at that part of our civilian life, it had a progression of capability over time. So now we're in this future state of this 10 or 12 years forward. LaserCom has worked well. What might have happened, and how could we sort of avoid some of those pitfalls we had in the cellular world? So I'll talk about three potential regrets. The first regret is we're using LaserCom in situations where it doesn't really need to be used, or where we're not highlighting its greatest features. I'm thinking to an example of a system application I saw recently. So the LaserCom system was kind of being compared to a microwave system. So you think between 20 gigahertz and 200 terahertz with the two options being considered. That's 4 orders of magnitude frequency or wavelength. And so in some metrics, right, that would be 8 orders of magnitude. The LaserCom system should have an advantage on. But to be conservative and try to avoid those failures that I said we didn't want to have for overall LaserCom, they chose sensitivities that were probably a couple of orders of magnitude off what you can conceivably achieve. They broadened the beam and took some jitter hits, so there was a couple other orders of magnitude. They were providing data rate that kind of exceeded the baseline mission, so there was a couple orders of magnitude. And pretty soon, you're looking at a LaserCom system, if you're the overall system developer, that you're comparing it to a system that's mature, relatively cheap, and meet my needs versus one where we've done LaserCom. Well, we've hedged our bets enough that they're about the same, but the LaserCom is perceived riskier. So what I advocate for is that when we choose our LaserCom systems, don't do that. Pick the ones that eat that, eke out 7 orders of magnitude improvement. Don't be satisfied with 1 or 2. You need to show its true capability and apply it. In many of the cases, we all know about deep space missions, small space missions. There's a whole variety of things that LaserCom is uniquely qualified to do. Well, let it be awesome. Let it shine. Let it use its unique capabilities. So that's the first regret we want to avoid, using LaserCom where we should. Another regret is if you think back, let's say we have these 10 or 12 different systems, multiple operators in each system, or multiple elements of each system, but they all can't work together. We've seen this in our cellular world from previous generations of cellular standards. We see it in military operations worlds where different platforms can't talk together, and it's incredibly frustrating. There's always good reasons to do that. I think from an interoperability standpoint, one, we do have to get the standards right. And generally, if you talk to anybody, their system has some unique features that require them to do it the way they do. They're happy if others use their standard, but there's some penalty if they use somebody else's standard. We all have to be open enough to say, when are we truly unique and which things can really be lumped together? And then we can have more users of the same standard. It'll give us more flexibility, allow us to do things we never thought about being done when we did the original system concept. There's Moore's law, microelectronics, or integrated circuits. There's something called Metcalfe's law in networks, which again is not based on physical law. It says the power of a network is proportional to the number of users squared. And so again, here, if we can have all these systems be successful in different applications, but then have the ability for them to interoperate, it'll make LaserComm even more capable and more of an enabler across a whole wide range of missions that you don't even think about when each individual system is coming out of the pipeline. Then the third regret, the last regret, is as these systems come online, there'll be incredible capabilities they deliver, and sometimes there'll be an appetite to stop there and say, listen, LaserComm is done. We've had a system. It works great. Let's go on and tackle other problems now and kind of move away from LaserComm. If I look at RF communications, right, that wasn't the case. We spent decades and the systems got better and better in each evolution. So as systems are coming online, we all need to argue to continue to have that technology development, whether it's different laser sources, whether it's sensitivity of detectors, whether it's integration of electronics. We across a whole variety of dimensions. But the first program successes should not stop the technology development. In fact, should be motivators to drive the technology development even harder to make the next generation of systems even better. So that's the comments I wanted to share today. I'm certainly happy to address questions or comments through the conference infrastructure. So just in summary, right, I'm a LaserComm advocate like many or most of the folks attending this conference. As those systems come online, and I'm now 10 or 15 years in the future with a dozen systems working in a whole variety of environments, let's avoid the regrets of putting them to work in environments that don't let the true unique benefits of LaserComm show. Let's avoid having them all be stovepipes and not talking to each other. And let's avoid the first ones stopping all the technology development. That's it. Thank you. I hope everyone enjoys the rest of the conference.